We're going to look today at calculating probabilities with a normal distribution, and we're going to compare the three different chapters we've done so far. So today's actually not something new, but it's reviewing and kind of putting it all together so you know the difference between them. So in chapter 2 and throughout the first semester, we've done a lot of probabilities with just X. X is a single event or an individual thing happening. And the symbols we're going to use here is that X is normally distributed with a mean of mu, or sometimes you'll see mu sub X, meaning this is the population mean, or this is the standard deviation of the population. So that's just an entire population. Here's the mean, here's the standard deviation. So that's what the symbols look like. Then we went on to chapter 7 where we combined random variables. So we did things like we took a random variable X plus a random variable Y and we calculated a new mean and a new standard deviation. We also combined the random variable X to itself. Okay, so in the next couple slides we're going to review and walk back through chapter 7. And then chapter 9, oh by the way, this slide is not in your PowerPoint at all. So make sure you write all this stuff down. Chapter 9, what we just did is we said, okay, well, X bar, which is the sampling distribution of sample means, all the sample means put together. Okay, we've got different ways to say this is normally distributed, but assuming it's normally distributed, it will have a mean of X. It will be the same mean as the population, and the standard deviation will be the standard deviation of the population over the square root of n. And then we can calculate probabilities based on that. So let's go through and talk about chapter 7 real quick as a quick review. And then you should be able to do some problems based on this. So if you remember, we had this gray box where we talked about combining two random variables. So here we have that if we want the mean of X plus Y, then very easily we just find the mean of X plus the mean of Y. If we want the mean of X minus Y, then we simply subtract them. If we want to multiply by a constant, then we multiply by a constant. If we want to add a constant, then we add a constant. These are all different ways to manipulate one or two random variables. Okay, so that's how we can calculate our new means for our normal distribution. Here's how we can calculate our new standard deviations. Well, essentially, we have to work in variance. So if we manipulate this formula, if we actually want the standard deviation of X plus or minus Y, it works the same, then we're going to have to take the square root of the variance of X plus the variance of Y. Again, that's whether or not you are adding or subtracting, you always add the variances together. So that's how we can get our new standard deviation. Okay, so this is chapter 7 stuff. If you're combining X and Y. So this is combining random variable X with random variable Y to get a new mean and a new standard deviation. Okay, so what else did we do in chapter 7? Well, we also did X plus X plus X, which unfortunately suddenly is not the same as 3X. This is a random height plus a random height plus a random height. So it's a lot of randomness going on, okay, which is not going to work out quite the same as 3X, specifically for the standard deviation, okay? So how does this change the mean? Well, it doesn't. So the mean will still be X plus X plus X, add the mean, add the mean, add the mean, or 3 times the mean, it doesn't matter. Okay, but if you're combining 3 random variables to get the new variance, you will need to add the 3 variances, and so you'll get 3 times the variance. So your new standard deviation will be the square root of 3. So if we square root this all to get the standard deviation will be the square root of 3 times the original standard deviation. If you're doing 3 times X, so one constant times a random variable, if you recall, we can do 3 squared times the variance or just 3 times the standard deviation. Okay, so in summary, if X is from a normal population with a mean of mu and a standard deviation of sigma, if you want X plus X plus X, you have that be normally distributed, it'll be 3 times that original mean and the square root of 3 times the standard deviation. But if you just want to multiply it by a constant, if you just want 3x, you're going to have 3 times the mean again, or 3 times the standard deviation. Okay, so that is a quick review of Chapter 7. So here we have x plus x plus x will be normally distributed with a mean of 3 times the mean of the population and a standard deviation of square root of 3 times the standard deviation of the population. Okay, or if we, now that could be 2, 3, 4, 5, 6, 7 times you're adding it together, it doesn't matter. This is just an example of 3. Or we can do x plus y, if you want that to be normally distributed, the new mean will be the mean of x plus the mean of y, and the new standard deviation will be what we talked about here. There's the variance, that's the formula for the variance, so you got to change everything to variance, add them together, then square root everything. So if we can squeeze that in here, the variance is going to be this, or the standard deviation is going to be the variances squared, or the variances individually added together and then square rooted. Okay, of course that's not very pretty, but hopefully you remember that from Chapter 7, and that will help us move forward when we're doing questions that involve Chapter 2 and 7 and 9 all in the same type of problem. So then we'll do some examples of this in class together. Have a great day.